Okay, so it's been a little while since I've even read this problem thoroughly and done it. So give me a second. With one method of a procedure called acceptance sampling, a sample of items is randomly selected without replacement, and the entire batch is accepted if every item in the sample is okay. So without replacement. To review, without replacement means if I have 10 items and I draw 3, those 3 don't ever get put back in. So when I draw 1, I only have 9 items for the next draw, so the denominator changes for probability. If I draw a second one, the third draw will only have 8 items. So the first has 10, the second has 9, the third has 8, and so on. Here, the ABC Electronics Company has just manufactured 1,200 CDs. So 1,200 CDs. Okay? And 110 of them are defective. So if we were just to think about drawing one out, what's the probability of getting a defective one? Well, that's 110 out of 1,200. Okay, 110 out of 1,200 to get one defective. If 4 of these CDs are randomly selected for testing, so we're going to draw 4 out, what is the probability that the entire batch will be accepted? So we have to think about, what does it take for the entire batch to be accepted? Remember, it says the entire batch is accepted if every item in the sample is okay. So in other words, we don't want this probability. We want its complement. We want the other probability. We want the probability of drawing good ones, because all 4 of them has to be good, and they'll accept the whole batch. So we really want 1,200 minus the 110. We want this probability, which is 1090. Okay, and then we have to draw 4 of them. So we have to draw 4 CDs. And drawing the first one will be 1,090 good ones out of 1,200. Drawing out the second one is no longer 1,090 because we're banking on the idea that we draw a good one, right? So we're going to have a chance of drawing a good one out of 1,089 because the first good one's already set aside. And we no longer have 1,200 in the bin or in our sample space. We have 1,199. So Naomi or whoever's watching this, hit pause and see if you can tell me the next 2 probabilities for drawing the third CD and the fourth CD. Okay, so the third one's going to be 1088 because remember it's without replacement. And we no longer have 1199, but we're drawing from a pool of 1198. And then the fourth one's going to be 1087 and 1197. So to find the probability of getting 4 good ones such that our batch will get accepted, we have to multiply those 4 numbers together. Okay? So this is going to be a little pain in the butt because it's going to be hard to see. But 1090 times 1089 times 1088 times 1087, all of that divided by 1,200 times 1199 times 1198. I'm saying times, but notice it's in the denominator. So I'm dividing by those, 1197. And so we have a 68% chance for the batch to get accepted. So 68.039, but they're going to want 0.6804. Okay, rounding out at 4 decimal places, that's 0.6804. All right, I hope this is helpful to anyone. Thanks, bye.